Hello there. Today we'll be doing number 48 of a Neetcode. We have Coco's eating banana problem. This is number 48 of 150. We're getting close to that 1/3 mark. Getting pretty close. Let's get this. So this is Coco's eating banana. We are given a pile of bananas and the number of hours we can spend to eat these bananas, and if we ate 4 bananas per an hour, we can eat this is the minimum number of bananas we need to eat per an hour to eat all of these bananas. So what that means is we have a 3, a 6, a 7, and 11. So again, these problems are all about getting information and understanding that information, and so that we can produce a solution. If we don't firmly understand the problem, it's very hard to find a solution. So let's say this is 4. It takes we spend 1 hour here. We spend 2 hours here. We need a total of 8. Basically, we have to do 4 times 2 because we can only spend a total of 1 hour at one spot. We have to spend that all at that one particular spot, so 2. And then this requires if we 4 times 2 is, so we just need the ceiling, so this is 2, and this is going to be 3. 4 times 3, so 3 hours here. So add these up and we have a total of 8, and so I don't think we can do any better than 8. We can try 3 and see what happens. Let's try 3. If we try 3, this will take 1, 3. This will take 2, 3. This will take 3, and this will take 4. And so that's just not possible, because well, that adds up to like 10. And so what we see here is that we have to round up, no matter like the number of bananas. So we have the piles, and we divide that by the bananas per hour. And with that, we can find out, that would give us the hours taken to eat bananas. And we can add all of those up for all piles, and we can get the total to get total hours taken. All right, so with that, we can take that and compare with H and make sure and get them in. How can we be so sure to we can just go through every single item with 3. We tried 3. We try the minimum item, and then we tried the maximum item. One way we can do it is to go down from the maximum item and go down to the minimum item, or take the minimum item and go into the maximum item, and until we find something that's more than the max. I mean, more than our min. Then we can exit, or less than our min, we can exit. So that's one way to do it. Another way is that we can do binary search between the number of bananas in the piles. That way we can reduce our search by the number of the size of the piles. So size 11. And I think that's very good. That is enormous savings. When you go from n to log n, it's like taking like think about 2 million points, then that like reduces take the log of 2 million, log 2 of 2 million. That's like, I don't know, that's much smaller. I don't know exactly what it is, but I know that you go from 8 to 3 and 16 to 4, 32 to 8. So it's going to be quite a lot smaller. So anyways, with 32 to 5, actually 5, my bad. So we can do binary search to look at each pile, and if they cross That means so basically what happens is we're gonna go left and we're gonna go right, and we start at, let's say, 1 banana an hour, and we go all the way till 11 bananas an hour. And let's try something in between, like 6 bananas, right? So what happens is that we're trying to eliminate the things that we don't need. So if we see that 6 bananas do not work, let's bring the R down to like past 6, like at 5, and try again. So we tried 3, and if 3 works, we move the L to the 4, and try that one. If 4 works, which it did, we'll move the R back down below the 3. So what happens is, if it works, let's move the L up to try something bigger, see if we can get more bananas per hour. If it doesn't work, let's move the R down, and that way we can see if we can get something working, because it's not possible. We'll try something else to see if something smaller will work. So that is how we will eliminate our options, and I think we can start coding out this problem. So let's say L and R is equal to 1 and the max of piles. That gets us the biggest item. The minimum eating speed, let's set that, is equal to the right pointer. That's because that's we might need to eat at that particular speed to get everything, because everything might be very big. So while L is less than or equal to R, that's how we always do a binary search. Bananas per an hour is equal to the L. Again, our way of getting binary search is R minus L divided by 2, because that way we don't index out of bounds sometimes. But like integer overflow. So hours taken currently is equal to 0 for this particular bananas per an hour, and we're going to create this bananas per an hour speed. So for pile in piles, and we're going to get hours taken. We're going to plus equals math dot ceiling of pile divided by the bananas per an hour. So we have, however large our pile is, we can eat X number of bananas per an hour, and that will give us the number of hours we need to take to. So basically, take the bananas away, and then we're left with hours. Okay, so we have X amount of hours taken to eat all those bananas. So we have total hours taken, I guess, to be more exact. So if total hours taken is less than or equal to the hours that are given to us, so we can try for something smaller, like we said. R equals M with bananas per an hour. Let's try for fewer bananas per an hour, 1 less bananas per an hour. Let's see what happens. Else, oh yeah, one more thing. If it works, we have to record it. So minimum eating speed is equal to the min of minimum eating speed and the total hours taken currently. Otherwise, let's move the L up so that we can try to eat more bananas per an hour, and see if we can make it in time. And with that, we can return the answer, which is the minimum eating speed that we need to eat all those bananas. Run. Uh-oh. We have an error. Total hours, comma. Crazy. Wrong answer. Okay, something's wrong. Let's see, 6 hours for some reason. Did we make a mistake somewhere? R minus L. Let's print out the minimum eating speed and find the error. $666. The variable seems to be okay. Let's print that out. 6, 10, and 8. What's going on? Why are we moving down? So we were successful, right? So we move down into our array. So why are we moving up? Not so sure about that. What's going on here? Okay, print LNR. So we have LNR is 1 and 5. 1 and 5. Okay. And then we have it's not total hours taken, it's bananas per an hour. That is the minimum eating speed. It's not the minimum number of hours taken. Let's submit that, and we should be good to go. That was quite the blunder. All right, it runs kind of slow, but it works. I think with that, I think you would have successfully passed your interview for this particular type of question. And because we were able to find the more ideal way of solving this, which is the log n, I think there was some unique way of using bisect according to something in the discussion section. And that's more to look into later. But in this particular problem, what we're trying to learn here is binary search and learning how to identify where we can use binary search to eliminate options and to get our particular answer, which is the bananas per an hour. That's what we're trying to get. And the reason why it wasn't working earlier was because I was collecting the total hours taken and the minimum number of hours taken possible, which we're not trying to do. We're trying to get as close to as many hours we can totally take, while getting the minimum. So it's getting the minimum number of bananas per an hour. I think instead of changing to this to minimum eating speed, that would cause this error. If we change this to minimum bananas per an hour, we will be able to recall what we're trying to do more easily, and that way we can solve this problem and write better code for someone else to read. If you have any questions, please comment below. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.